Hey there, Math Hoppers! In this video lesson, we'll learn how to solve linear systems using the elimination or combination method. A quick review of what a linear system is. Remember that linear systems are two or more linear equations that are solved together. For this video lesson, we are going to concentrate on linear systems with two equations. So if we're going to solve the two equations together, the solution to this system has to be the coordinate point that makes both equations true. Now, think about what a linear equation is. When we graph it, we get a straight line. So we have a linear system graphed on the screen right here. And the solution to this linear system and to any linear system with two equations is going to be the intersection of those two lines. Because if you have an intersection point, that's clearly the point that lies on both graphs. The solution to this system is 2, 4, because it is where the graphs intersect. All right, when we say solve using the elimination or combination method, it's the same method. Some books call it the elimination method because we're eliminating one of the variables. Some books call it the combination method because we eliminate a variable by combining the two equations using addition. Okay, so what do we need to do for this method? To eliminate a variable, we need opposite coefficients on one of the variables so that when we add the two equations together, those opposite values cancel out and we will eliminate a variable. So we need 1/2, -1/2, 3, -3, 2, -2 as coefficients on either the x variable or the y variable. Looking at this equation, we already have opposite coefficients on the y variable. We have positive 2y and negative 2y. That's exactly what we're looking for. So, since we already have opposite coefficients, our next step is simply to add the two equations and see that the y variable will be eliminated. All right, when we add the two equations, we're going to get 3x plus 5x. That's going to be 8x. 2y plus -2y will give us 0y. That will mean we have no y term anymore. And 4 plus -4 will be 0. Don't think that you made a mistake. A lot of people, when we get a 0 in the constant, think, oh no, I've made a mistake. Totally okay. We can take 0 and divide 0 by a number. We simply can't divide by 0. That's why people get a little confused. They get a little freaked out when they see a 0 right here. Okay, so this 0y, you would never actually write that when you're doing this. 0y makes no sense. If there are 0 y's, then why even talk about it? So let's cross that out. Now we're left with 8x equals 0. X is not isolated. We haven't solved for x yet. We still have an 8 with the x. How is it attached? It's attached with multiplication. What's the opposite of multiplying by 8? Dividing by 8. So let's divide both sides of the equation by 8. When we do so, 8 divided by 8 is 1. We're left with x equals 0, because 0 divided by 8 is 0. If I have $0 and I share it equally among 8 of my friends, all 8 friends get $0. That's how that works. Okay, so we have half the battle. We know that x equals 0, so we're going to plug 0 in for x into one of the original equations and then solve for y. But we've run out of room, so let's move everything up. Okay, so we're going to plug 0 in for x in one of the equations. It does not matter which equation you choose. I generally say choose the easier equation. Not sure that one is terribly easier than the other, but I'm going to choose the top equation because at least they're all positive values. So if I take 3x plus 2y equals 4, put 0 in for x, 3 times 0 right here will give me 0. I will be left with 2y equals 4. Again, y is not isolated yet. We have to divide by 2 because the 2 is multiplied. Divide both sides of the equation by 2. We get y equals 2. All right, now we know the x coordinate, we know the y coordinate. The solution is 0, 2. Remember, this is an intersection of two lines, so we write the solution as a coordinate point. Okay, well that last one was really easy because we already had opposite coefficients. Looking at this system, x plus 2y equals 5 and 5x minus y equals 3, we do not already have opposite coefficients on either x or y. So that means we have to either multiply one or both of these equations by some constant to create opposite coefficients, either for x or y, it doesn't matter. So if you're looking at this, I like to look for a value of 1 as a coefficient, 1 or -1. So here in the top equation, we have 1x plus 2y equals 5. So I could create opposites for x. I could multiply this entire equation by -5, then I would have -5x and 5x. But look right here, I already have opposite signs. I have 2y and negative 1y. I have opposite signs and one of the values, one of the coefficients is 1. I would use this and eliminate the y variable because I don't like multiplying by a negative unless I absolutely have to, because it increases the chances I make a mistake and forget my sign. So look for coefficients that already have opposite signs where one of the coefficients is 1. Now, if you're really good with multiplying by negatives, and we all should be at this point, then go ahead and use the x and 5x. Some people really just like eliminating x if it's possible. Also, if the y terms or the y coefficients had really large numbers but opposite signs, you might want to go with x because some people avoid using really large numbers because you're going to multiply it by a constant and make it even bigger. Okay, so what we're going to do is eliminate the y terms. We're going to multiply the bottom equation by 2. Why are we doing that? Because then that will create a 2y and a negative 2y, and when I add them, the y variable will be eliminated. We could, remember, also multiply the top equation by negative 5 and get rid of the x terms, but we're choosing the option where we already have opposite signs, and we get to multiply by a positive value. Okay, so the top equation remains the same. Bottom equation, you're going to multiply every single term by 2. Remember, when we add or subtract like terms, but multiplying, we have to multiply everything. So do not forget to distribute. We get 2 times 5x, that's 10x. 2 times negative y is negative 2y. 2 times 3 is 6. So we have a new equation. It's really an equivalent equation. This equation is equivalent to the bottom equation we started with. It's just increased by a factor of 2. We're going to replace the original equation with this one so that we have opposite coefficients. Let's look at our new system. We now have x plus 2y equals 5 and 10x minus 2y equals 6. This is our new system. We've created it because we have opposite coefficients. Now we're just going to add the two equations and eliminate that y variable. So adding this, remember, x means 1x. So we have x plus 10x is 11x. 2y plus negative 2y is 0y. And 5 plus 6 is 11. Let's just eliminate the y's right now. Let's not write 0y again. And we get 11x equals 11. Well, x is not alone yet. We have an 11 that's multiplied to it. Opposite of multiplying by 11 is dividing by 11. Divide both sides by 11. We get x equals 1. Again, that's half the battle. We know x equals 1, so we're going to plug 1 into x for the original equation, one of the original equations, it matters not which one we choose, and solve for y. Now, in this case, I really do think the top equation is much easier to plug x in. So here we have x plus 2y equals 5. If I just pop a 1 in there for x, it's very easy. I could use the bottom equation, but I'd have to multiply 5 times 1, get 5. It's a little multiplication, it's not hard. But we're going to choose the top equation. We're going to pick x plus 2y equals 5 and plug 1 in for x. So we get 1 plus 2y equals 5. Now we're going to solve for y. First thing we're going to eliminate is the number that is added or subtracted. Remember, we work furthest from the variable we're solving for when we solve linear equations. So what's the opposite of positive 1? Negative 1. So we'll subtract 1 from both sides. We'll be left with 2y equals 4. This looks very familiar. Opposite of multiplying by 2 is dividing by 2. So we'll divide both sides of the equation by 2 and get y equals 2. Okay, remember we already knew x equals 1. Now we know y equals 2. The solution is the coordinate point 1, 2. All right, very nice. Let's look at this system. Not only do we not have opposite coefficients already, we actually can't create either coefficient from the other. And let's see what I'm talking about. I can't create a negative 3x from 4x, and I can't create a negative 4x from 3x. So I can't create opposite coefficients here, and I can't do it with y either. Now, I already have opposite signs on y, so that's good, but I can't create an 8 from a 5, and I can't create 5 from an 8. So when this happens, when you can't simply multiply one equation to get the opposite of the other coefficient, you'll have to multiply both equations. Looking again at what I mean. 3x and 4x, I can't create 4x from 3x, or actually I can't create negative 4x from 3x. And I can't do it with y. I can't create an 8y from 5y. So I'm going to have to multiply both equations by something. So let's lose that one-sided bracket. Let's look at our system. We have two options here. When we do this, we're going to multiply each of the equations by some version of what's here. So I could take this top equation and multiply it by a negative 4x. That would give me negative 12x, and then multiply the bottom equation by 3x. That would give me a positive 12x. Okay, so you could eliminate the x variables by creating 12x and negative 12x, however you want. You can multiply the top by negative 4, you can multiply the top by 4 and the bottom by negative 3, doesn't matter. Or you can create 40y and negative 40y. All right, so I know we like to avoid multiplying by negative, but if we create 40y and negative 40y, I'm going to be multiplying 19 by 8, which is pretty ugly. I mean, 8 times 3 is not that bad. 8 times 5 is not that bad. But I'm going to stick with smaller numbers here. Let's multiply the first equation by negative 4, and that'll give me my negative 12x. And then the second equation by 3, and that'll give me positive 12x. So when we do that, do not forget to distribute. All right, negative 4 times 3x is negative 12x. Negative 4 times 5y is going to be negative 20y. And negative 4 times 19 is going to be negative 76. Let's put that all down. Let's distribute the second equation. 3 times 4x is 12x. 3 times negative 8y is negative 24y. 3 times negative 4 is negative 12. So putting that equation down, that is our new system. We're going to put this system, we'll move it up a little bit, put it in a little one-sided bracket. Now we have a new system that we have opposite coefficients for the x variable. So we're going to add the two equations and eliminate x. When we do that, we will see that negative 12x and 12x is going to be 0x. Those will be eliminated. So let's just eliminate them right now. And we have negative 20y plus negative 24y is going to give us negative 44y. And negative 76 plus negative 12 is negative 88. Yeah, the numbers are a little big here, but it's better than if we had eliminated y. Okay, so let's put our new equation. Negative 44y equals negative 88. All right, y is not alone. We have a negative 44 that's multiplied to it. The opposite of multiplying by negative 44 is dividing by negative 44, not positive 44 like it says. So we're going to divide both sides of the equation by negative 44, and we get y equals 2. All right, so that's half the battle. We know that y equals 2. We're going to plug 2 in for y into either of the original equations and solve for x. All right, so which equation is easier to use? Actually, they both kind of stink. They both have a lot going on. It does not matter which one you choose. So let's just choose one. Let's choose, for argument's sake, the bottom equation, right? So we'll do 4x minus 8 times 2 equals negative 4. So 4x minus 8 times 2 is negative 4. 4x minus 16 equals negative 4. Now let's just solve for x. We solve for x, remember, by going from the furthest from the variable. That's the negative 16. The opposite of negative 16 is positive 16. So we add 16 to both sides of the equation. We get 4x equals 12. 4 is multiplied to x. Opposite of multiplying by 4 is dividing by 4. So we divide both sides by 4. We get x equals 3. Okay, we know x equals 3. We already knew y equaled 2. The solution is 3, 2. Make sure to put the 3 in the x position and the 2 in the y position. That's another common mistake that's made. Another common incorrect answer on a multiple choice test would be 2, 3. So just be careful. A lot of times, since we solved for y first, people tend to put that in the x position. Make sure when you write your answer that your coordinates are actually the x coordinate and the y coordinate in the right space. Okay, so let's review the steps for using the elimination or combination method, and we will call it a lesson. Okay, first, if there are not opposite coefficients for either x or y, multiply one or both of the equations by a constant so that one of the variables, either x or y, has opposite coefficients. Once you have opposite coefficients, you need to add those two equations together to eliminate one of the variables. Once you've eliminated one of the variables, you're left with simply an equation with one unknown. Solve the equation for that unknown, and then plug that value back into one of the original equations to solve for the other variable. It sounds worse than it is. When you get into these, they're not too bad. You still have questions? You should be subscribed to our YouTube channel. Send those questions to me, and I'll make you a custom math video. Till next time, Math Hoppers, take it easy.